Hi, so in today's seminar, I would like to talk more about clean architecture in the context of Flutter. So basically, clean architecture is introduced by Robert C, and this architecture comes with a lot of advantage and flexibility. But when speaking in the context of Flutter, actually this clean architecture is a little bit modified to suit the advantages and needs of Flutter. So actually here we are having different layers, and clean architecture is mainly emphasizes, or it's mainly concerned about the different separation of layers and separating of concerns between different layers, so that the code will be more flexible and robust for scalability and testing. So then coming to clean architecture along with Flutter, we'll be having three different layers: data layer, domain layer, and presentation layer. So data layer will be responsible for interacting with all the data which are coming from either API or from the databases. So this data layer will be responsible for collecting all the server or local data and dealing or providing that data to our application. And in the data layer itself, we will be having another repository. So this repository will act as in between, a bridge between the domain layer and the data layer. So this repository will actually filter or do the needful functions in the data which has been given from the data layer, and it will be transferred that to the domain layer. So this data layer basically deals with all the data that are coming and outgoing from our application. And when coming with the domain layer, actually this domain layer which is responsible for holding the business logic, and this domain layer doesn't change that much throughout the lifetime of our application. And this domain layer act as making a rigid format for our application. So whatever data is coming from the data layer will be gone through this domain layer, then only it can reach the presentation layer. So it will always have to follow a rigid and strong path or schema for the data transferation from one end of the application to the another end, which is from the data layer to the presentation layer. So this business layer also has a repository, but here the repository will be as an abstract class, and this abstract class will be actually implemented in the data layer, so that if someone else is developing the backend, or a developer who is developing the backend, need to be basically implement all the functions which has been defined in the domain layer, so that makes our application less error prone, free. So that's the usage of data layer. And in the data layer we can also found the entities. So these entities are like the classes which helps us to pass object data in a as format of object. So and these entities will be also extended in the data layer as models. So basically both of them are same, but due to the separation of concerns we can't use these entities in the data layer. So for that, like, we have to use models which will by default extends the entities, so that there also we have giving a rigid format for data processing in our application. And to connect this domain layer with the presentation layer, we have use cases. So this use cases is nothing but it's a simple thing which is the only condition for making use case is that we can make as much as use case we want, but the only thing we need to take care about that the one use case can be only responsible for performing a single operation or a single function in our application. So we can create as much as use cases we want, but we need to take care that a single use case is only performing a single action in our application. So these use cases will be directly called from our presentation layer. And when coming to the presentation layer, we will have again three sub folders or sub layers. One will be like our presentation logic. Basically we will write all this state management packages, like either block, provider, get it, all this kind of state management UI logics, UI state management can be done over this presentation logic layer. And next we will be having the screens and the widgets. So it's like basically Flutter thing. So in screens, like, we will be returning all the screens and the pages or the scaffolds where we need to display all the UI data. And in the widgets we are writing all the reusable data which can be used throughout the feature. And when coming to the data layer, when coming to the presentation logic layer as like block or other state managements. So currently I thought of going with block, because like whenever we see in the industry, like, we can see that block has been mostly used with the clean architecture because of the much more flexibility and the robust nature of block state management. So when coming to block, like, we can directly call these use cases from the block to manage or to access the data from the domain layer. And when coming to the clean architecture, the second most important thing is that about the dependency injection. So dependency injection, like in the context of Flutter, basically we can use either provider package or get-it package. So mostly we can see that the get-it package has been widely used by the developers because of its intelligent nature and because of its easiness to use. So we can create a global instance for our get-it package, and after that, wherever we need that, we can like register all these repositories, data layers, and all the use cases, like different layers and its functionalities to the service locator. Service locator is a common name which has been given to the get-it package. So after giving all these repositories and giving all these data layers and functions registered to the get-it instance, then after whenever we need this, we can directly call this get-it instance, and we can fetch all these registered repositories and registered dependencies from get-it instance. So that will make our application less dependent to the other layers. So it also makes us very easy to code, and it also reduces a lot of boilerplate codes in our application. So it will be much more readable and much more easy to navigate. And when coming to the advantages of clean architecture, actually it gives us a more robust and a more rigid structure for our application. That's a one and main advantage. And the second thing is that the flexibility or the scalability. So if suppose like currently we are doing our application in a Firebase database, so in future if we wanted to change the database to something like a custom database, like a database which is created from Node.js or some kind of backend server, so like we are using our own custom server, then if you are using clean architecture, it will be much more easy and efficient way to convert that, because if whatever changes we are making in the data won't affect to the domain layer or to the UI layer, so there we doesn't have to make any changes to both those two layers. We can, by making changes to only the data source in the data layer, we can completely change our applications server from this currently using Firebase server to any other server we want. So that will be much more easy for a kind of application where we are looking, or where we are giving more priority to the scalability factor. And also when coming to the domain layer, if you wanted to make any core business changes or any core application changes, then if you have just make the changes in the domain layer, then it will be like given us the warning to manually change those necessary changes to the either data layer or to the presentation layer. So it will be also useful for us to not miss out any of the important things in our upgradation or in the changes of our process. So the upgradability gives us a more importance to clean architecture. And the another most advantages is that when you are using clean architecture, our code will be more structured and more readable. So if you want to make any changes in the future, we can easily understand what we have done in the past. So that's also another great advantage of clean architecture. Thank you.